Inverse function is one of the most memorable topic because inverse function was my interview question. So let me tell you what was my interview question. You have 10 to 15 minutes to teach inverse function to the high-end committee members. So you have to assume that they know nothing about inverse function. So you have 10 to 15 minutes, teach them what it is. Of course, you have to teach everything in your own word. Reading off the book is not going to work. So here is how I explain inverse function to them. So let's start. Inverse function, graph, domain, and range, and I also want to teach a verification. So the first set of functions that I would like to use is, look at the blue one. So we have f of x equals to 2x plus 4. Equation is you change the f of x to y is equals to 2x plus 4. And then the green function, I use f negative 1x. So what is this? F negative 1x. This is not f raised to the negative 1 power. This is f inverse of x. Once again, f inverse of x. The negative 1 stands for inverse. It is not an exponent. Equals to 1/2 x minus 2. So for equation, you use y negative 1. That means y inverse equals to 1/2 x minus 2. Now, for inverse function and a function, you have to know this, you have to study this immediately. The domain of the function is the range of the inverse. The range of the function is the domain of f inverse. So what does that mean? This is the first thing you have to learn from inverse function. So let's take a look at the graph of the blue and the green function. So look at my first graph right over here. So we have the function 2x plus 4. This is a straight line. Do you see this? 2x plus 4. This is a straight line. And then the inverse function, 1/2 x minus 2 is also a straight line, a blue straight line, and a green straight line. And then I also show you the graph of y equals to x. I will explain what it is in a minute. Now, so for the blue function and the green function, let's take a look at the blue function. Which point did I take a look at? I take a look at when x is equals to negative 4. So when you plug in x equals to negative 4 to the blue function, y is equals to negative 4. So negative a plus 4 is equals to negative 4. So negative 4 comma negative 4 is a point on the blue line. And then when x equals to negative 2, y is equals to 0, x equals to negative 1, y is equals to 2, x equals to 0, y equals to 4, 1 comma 6, and 2 comma 8. These are the points on the blue function. All right, so how about the green function? The green function, I pick x equals to negative 4, y equals to negative 4, and then x equals to 0, to 2, to 4, to 6, and to 8. So I have 6 points on the green line as well. Now, do you see any patterns between these 2 points? What can you say about these points? Let's take a look. Negative 4, negative 4. I'm not going to worry about that. I would like to look at negative 2, 0. Look at the blue line. When x is equals to negative 2, y is equals to 0. Can you look over to the other side? When on the green line, when x equals to 0, y equals to negative 2. So it looks like the x and the y just interchange after you look over the y equals to x. Let's take a look at this one. X equals to 1, y equals to 2. If you look over to the other side, you have 2, negative 1. So it looks like the x and the y coordinate, they swap after you look over to the y equals to x. And then what else? 0, 4. And 4, 0, they switch, right? 1, 6, 6, 1, they switch. 2, 8, 8, 2, switch. Now, what did I say here? The domain of f. What is domain? Domain means x. What about range? Range means y. So that means the x of the function of f is equals to the y of the inverse. Now, let's take a look. This is x, right? So x equals to negative 2 is the same thing as the y of the inverse. And then on the other hand, the range of f, which is 0, is equals to the domain of inverse, which is right over here. They just got swapped. So the domain of f is the range of the inverse. The range of f is the domain of f of inverse. So let's do a function evaluation. So when x is equals to 1 as the input, what do we get? You don't see that point on the graph. When x is equals to 1, you have 2 times 1 plus 4, that is equals to 8, right? So when x is equals to 1, when x is equals to 1, 2 plus 4 is equals to 6. Actually, this point is on the curve. And then, what is 6 equals to? 6 is my output, right? So domain and range, domain is x, range is y, or you can use input and output. Now, I am going to put this 6 inside the inverse. So this is 6. I would just say x equals to 6. That looks way better. So when x is equals to 6, but you are putting this function in the inverse, right? So when you put something in a function, you take that as an input. So therefore, x equals to 6 is actually the input of the inverse. So what do you get? You get 1/2 times 6, which is equals to 3, and then 3 minus 2, which is equals to 1, and 1 is the output. Now, what do you see here? The y equals to 1, the output is actually the input of the function. So if this is how you do it using algebra, and then this is how you do it use a graph, and then also, what if you just draw a simple picture? So do you still remember this? I said that whenever you evaluate a function, you treat function as a machine. So this is a machine. This blue box is a machine. You let x equals to 1, which is the input. It's like, how about a vending machine? So this is a blue vending machine. X equals to 1 is your money. So you input some money into the machine, and then the output is y equals to 6. So I'm going to write y equals to 6. So this is your output. The output is the merchandise, the soda, the drink. And then you are holding your drink, right? Your drink is y equals to 6. Now you are going to move on to the inverse function, which is another machine, or you can think about the corresponding machine. And this time you are going to insert the drink back to the machine. I am talking about this green machine. You are holding your drink. Your drink is y equals to 6. Now you toss the drink back to the machine, and then this 6, since you are putting this into the machine, you take that as an input. So you put your drink into the machine, and then what do you get for the output? The output is you will get your money back. So the y equals to 1 is the output of the inverse, which is the range of the inverse. Do you see this? This is the range. I should match the color. This is the range of the inverse. What is that equals to? The range of the inverse is actually equals to the domain of f. So the range of inverse is actually equals to the domain of f. So this is why I said the domain of f is the range of f inverse, and then the range of f is the domain of f of inverse. That's why when you look at the graph, we should take a look at the next one. So the next graph, I have two functions, f of x equals to the square root of x, and then the inverse function is f inverse of x equals to x squared. So this one I will only consider when x is greater than or equal to 0, because for the x squared, if you don't take x, if you do not consider x greater than or equal to 0 only, you will have a full parabola. Now, in the function, we have a red function, right? So the red function is right over here. You have a square root function, and then you have a half parabola. Let's take a look at the point. The first point is 0, 0, and then the second point is 1, 1. This point, they are not that interesting because it doesn't matter how you swap them. You still get 0, 0, and 1, 1, right? So this is the point that you have to look at. 4, 2, and 2, 4. So for 4, 2, when x is equals to 4, the square root of 4 is equals to 2. And then on the other side, you look at the inverse function. When x is equals to 2, y is equals to 4. So you are taking this. You are taking the 2, the output, and then you put it in to the square, and then you get the 4 back. This is how the inverse function works. What else? The next point is 9, 3. The square root of 9 is equals to 3. Now you take the 3, you put it back to the x squared, you get your 9 back. So what I'm trying to say is, when you put the function and its inverse on the same graph, you get a reflection. Basically, if you have 9, 3 in the function, then when you look at the other side, you look at the inverse function, all you have to do is you swap the x and y. So when you swap the x and y, the domain and range is switched. So that's why I said this so many times. When you look back to the very beginning, the domain of f is the range of f inverse. And then the range of f is the domain of f inverse. So the x and y got switched. Now, let's take a look at the domain of the function. So what is the domain of the square root of x? This is x greater than or equal to 0, right? And then for the y is always positive, y is greater than or equal to 0. And then you will put this here. So all you have to do is you change the y to x, so this becomes x greater than or equal to 0. And then this one you switch as well, that becomes y greater than or equal to 0. So that means I give you a function, and then without telling you what the inverse function is, so let's say I give you a random function, okay, random function, what f of x equals to whatever it is, and then you figure out the domain of f and then the range of f, and then without looking at the domain, without looking at the f inverse, all you have to do is you swap the domain and range and then call them the domain and range of the f inverse. So this is the domain and range of f inverse, which is true when you look at the parabola x and y, they are both greater than or equal to 0. And then playing around with the x equals to 9, so when x is equals to 9, let's say you don't see the picture at all, so this is the square root of 9, which is equals to 3, right? And then you put the x equals to 3 as the input, because this is output. X equals to 9 is input. So now you use the output as an input. What do you get? You get a 3 square, which is equals to 9. So this is the output, which is the range of the inverse, which is equals to the domain of f. You swap the x and y. So you swap the x and y because of the y equals to x. So what is the y equals to x? So here is a conclusion. The f and its inverse are the reflection of each other, and you have y equals to x, you let them interchange the domain and range. Because y equals to x, when you put this in a complete sentence, x is y, y is x, so since they are the same, it is okay to just switch them. And then here is another way to picture the inverse function. I will have to ask you to use your imagination. We done the graph, we done the function evaluation, and then we have done the machine, right? The input and output thing. There is another way to picture or imagine inverse function in your mind. So now, think about this. You are standing in front of a mirror. You are looking at yourself, right? You are standing in front of your mirror. Now, do something for me. Lift up your left hand. Use your index finger to tap on the mirror. Yeah, what do you see? You are using your left hand. Your index finger is touching the mirror. Now, when you look into the mirror, do you see that your reflection is touching your index finger as well? Agree? Do you agree with that? You are lifting your left hand and then use your index finger to touch the mirror. Now, look into the mirror. Your reflection is also touching your index finger, right? Now, I want you to do one more imagination for me. Suppose you are the reflection in the mirror. Can you do that? Suppose, don't let your hand go. Suppose you are the inflection inside the mirror. Do we agree that the inflection person is lifting up the right hand? Let's do this all over again. Standing in front of a mirror. Lift up your left hand. Use your left hand to touch the mirror. Now, you see that your reflection is touching your left hand or your index finger, right? Now, I want you to do a role switch. Suppose you are the inflection inside the mirror. Do we agree that the inflection person is holding up the right hand? Right? So that means your left hand is equals to the right hand of the reflection. This is similar to the domain of f is the range of inverse, and then the range of f is equals to the domain of the f inverse. So back to this example, you are standing in front of your mirror, your left hand is equals to the right hand of the reflection, And then if you do one more thing for me, if you put your right hand on the mirror, then your right hand is equals to the left hand of the reflection person. So that's how the inverse function works. If you just consider the definition of inverse, inverse means you switch around, right? So your left hand is equals to the right hand of the reflection, and then your right hand is equals to the left hand of the reflection. So when you look at yourself, when you look at your reflection, your left hand and right hand, they actually switch. So the switch, I should use a quotation mark. That's how the inverse function, that's how the inverse function works. And then the y equals to x represent the mirror. So if you go back to this picture right here, you are the square root of x, your reflection is the half parabola, and then the mirror is y equals to x. So that's how I teach inverse function in my own word. Now we have a little bit more to go over. So now they are the reflection, and then what did I say? Y equals to x, let them interchange the domain and range. So when x is equals to 9/3 on the function, and then the inverse function, all you have to do is you switch the x and y intercept, and then to what is the y equals to x works. Why do we need to know the y equals to x? Why don't we just call that there exists a reflection? So here is why we need to know y equals to x, because that helps me to verify that they are the inverse function. So when you verify inverse function, you have to do a composite function. F of f inverse is equals to x, and f inverse of f is equals to x. So I gave you these two sample functions. So let's do a quick verification. So this one, f of f inverse, so you put the f of inverse inside, and then the function is 2 times x plus 4, right? And then you put the inverse function right over here, and then do a quick math. You can see that this is equals to x, right? So you have did I do this right? 2x plus 4, 1/2 x minus 2, huh? 1/2 x minus 2. This is supposed to be a minus 2. If I have a plus 2, that is not equals to x. Okay, before I erase that, do we agree that if this is a plus 2, we are not going to get x, we are going to get 4x plus 4, right? So change that to minus 2 because that's what I gave you. So what do you get here? So here you have a x, right? You have x, and then you have a minus 4, and then a plus 4. So now you have an x. And then f inverse, you have a f inverse of 2x plus 4, and then you have 1/2 x minus 2, and then the f of x is 2x plus 4, and then this one, you do the math, you have a x plus 2 minus 2, which is equals to x. This is a check, this is a check. And then for the other pair, let's do it really quick. So f of the inverse is x squared. So you're actually taking the square root of a square, that is equals to x. And then f inverse of f, which is square root of x. So this time you are square a square root. This is equals to x. Now you actually, this is a pretty convenient mistake. If I change this to 1/2 x plus 2, then what does that mean? You are not going to get an x, right? The composite function is not going to equals to x. That means the 1/2 x plus 2 is not an inverse function of 2x plus 4. If you don't get equals to x at the end, this x is y equals to x, is the mirror. Is the mirror, a place to let the function and its inverse interchange the domain and range, or interchange the x and y. Alright, so that is the end of this video. If you like the way I explain inverse function, give me a thumbs up, a subscribe, and I will meet you all in the next lesson. Signing out.